Hosting provided by Host Tornado. They offer website hosting packages, dedicated servers, and VPS solutions. Host.t.net. Programming Throwdown, episode 25, unit testing. Take it away, Patrick.
All right, so I've been accused before, not necessarily on this podcast, but my friends, of being eccentric.
Okay.
So to continue my trend of eccentricity.
And on the podcast, you're eccentric.
Ah! Man.
Been accused.
No, I've been accused. All right, so my newest eccentric hobby is taking film pictures and developing them myself. So
that's pretty nuts.
I guess film is kind of considered by many people to be dead, and long live the digital camera. And I do have a digital camera. I have a nice digital camera, an SLR, and I take pictures and I enjoy it. And so it got me thinking, like, I want to do something like, different. I see these people like taking pictures and film and like all this special stuff, and it's kind of crazy.
Yeah.
And I began to be very intrigued because film went away kind of when I was just coming into kind of understanding it, right? So like I was still, I guess probably like in like middle school and early high school, and the first digital cameras that people had and were using started coming about. And so when you're that age and you're not into photography, like I'd taken some pictures with the 35 millimeter camera or whatever, and then just sent them off to the lab and they come back. And I always just thought this idea of like people having this dark room in their house, like, oh, this is like really intriguing, and like I would love to do that because it's basically chemistry.
So let me get straight. So you have a room that's completely pitch black, kind of like a prison cell or something, and then
you would think, because that's always the image I had in my head.
Yeah.
But no, that's not the way it works, or
Really?
at least you don't have to. So I came up with this process on my own, and then it turns out it actually has a name. It's called the hybrid process.
Oh, okay.
So the way this works is I got a really cheap plastic film camera, but it doesn't shoot 35 millimeter film. It shoots what's called medium format film, which is 5 times bigger than a 35 millimeter area of image size. So you can get really large negatives from it. But the camera is like this cheap plastic camera made in China. It's called the Holga. It's like famous for like being artsy, and it has like only 2 settings. It has like 2 different aperture settings and 2 different shutters, like one shutter speed and then like what they call bulb, where you can just hold it open as long as you want.
Oh, okay.
Which basically means your picture will probably be messed up.
Like completely white or something?
Yeah. Exactly. Which is what happened to me a couple times. So I got this film, I got this camera, and I shot some pictures with it, and I'm like, I'm going to develop, and I use black and white film because the development process is a lot easier. And so it turns out the way that, maybe it's always been this way, but what you need is you need a dark room to move the film from the camera to what's called the tank. So you have like this little tank, which is a black cylinder that has a lid on it and a very cleverly designed like funnel and center tube, and then what's called a reel where the film goes. So no light can get in even when you take the top off. So once it's in there, so you have to go into pitch black and like take the film out and load it into this little, so much engineering. It's actually really fascinating. But in the pitch black, you put it in this reel and you do this like twisty motion, and it sucks the film up into a spiral with space in between so the chemicals can go in. And then you load it up into this tank.
And everything's done in there.
Yes, and so everything's done in there. So once you load it, then you can turn the lights back on, and the film's just in there. And then you pour the first chemical in, time it, dump it out, pour the second chemical in, and you do this until it's done. And so I did it for the first time this weekend.
Yeah. How did it turn out?
You can look on I did on my public Google Plus page, so people can actually see it.
Nice.
So it's terrible. I only got like 2 what I would call like actual images, and then a bunch of blurry things and bad, and then a bunch of like overexposed stuff, because I was doing this the completely non-engineer way. Like I created all the variables at once. So it was a new camera, a new process, new everything, right? So I had no idea what I was doing.
It's pretty cool, though.
But I'm pretty encouraged. Yeah, so I got one picture that I thought was like really good, and one was underexposed. So I've got some problems. I'm working through them. This is fun.
It looks like you were a sniper in the Russian front in World War II.
Okay, so you're looking at this picture of this is outside of my house. So, so yeah, it looks like it looks like a single frame from an old movie.
Yeah.
So part of that is my development unskill. Part of it is the fact that it's the film and it's black and white, and a lot of it's too dark. But it was very fascinating to me, and it worked first time. So what I did was shoot the film, develop it, let it dry, and then I scanned it on a scanner. And I don't have a fancy, nice scanner or whatever. But yeah, so I'm gonna try to improve it, try to be better, and I'm doing this not because it's cheaper or like I think it's more awesome. It's just interesting to me
to be more eccentric.
It's like chemistry.
Yeah,
I always thought it'd be fascinating, and I always like wanted to do it. So
I got my cousin's, my second cousin, I believe that's what you called your cousin's kids.
I got my
Sure.
second cousin's chemistry set, and it said on there, like, their big selling point was that you could eat everything in it.
Yeah, because that's what I want in a chemistry set.
And I was like, this is the weakest chemistry set ever. So then we went,
Including
and
the box.
We bought magnesium strips that day. I was like, I'm going to teach you kids real chemistry. Here's a bomb. All right.
Oh,
So-
now we're gonna. No, he doesn't mean that. He's just kidding.
No, I mean magnesium strips, like for fireworks and things like that. I mean,
Okay.
isn't that a firework? Anyways,
All right. Anyways, but I thought this was cool. This is my new hobby, new eccentricity,
pretty awesome.
and we'll
Pretty
see.
awesome.
We'll see if I make good pictures.
I also have a new hobby, but it hasn't come to fruition quite yet. It's not a new hobby; it's just a new project. So,
Oh, a new project. Okay.
Yeah.
Okay. Secret project.
yeah, secret project number.
Are you
4
gonna
million.
be a multimillionaire next time we meet?
Maybe. Well, we won't meet next time if I'm multimillionaire. I'll be on
Oh,
my
you wouldn't
yacht.
talk to me anymore? That's so sad.
Not like that.
Sure,
All
I'm
right.
not talking to you anymore. So on to
So,
tech news.
On tech news, we have Flat Pixels, which is it's actually sort of a blog post, an article on different design patterns, especially with mobile. And I thought it was kind of interesting. It actually goes over a bunch of different like competing motifs in mobile, and so it kind of talks about, Apple's known for having that very texture-based feel. So even
Skeuomorphic.
is that what that's called?
I think when you make something that's not real, try to look like something real. Like you add like leather stitching
Oh,
on the
yeah.
side,
Yeah.
and you try to make it look like a real object.
Yep. So Apple's notorious for that, and they've almost, according to this article at least, they've almost overused it. And now people are wanting something that feels more like I'm not in the real world. So they want to take something that feels very more abstract. And so you're seeing this shift. First, you had this shift towards realism. And that's one of the things that made the iPhone so cool, was because it felt like a real thing. And you have the Kindle, which sort of feels like real paper and things like that. That was sort of the trend, or sort of looks, not feels, but looks like real paper with the e-ink. And now you're sort of switching back to this sort of Tron-esque. Let's go back to the very like 8-bit retro, blocky style. And so that has its own appeal. And so this person, who I'm assuming is a good designer, but basically at least they're an educated designer. I don't know anything about their work.
Well-spoken,
but
maybe.
Well-spoken, educated. Kind of sort of discusses these different paradigms, and I thought it was a pretty interesting article. So give it a look.
Okay, so talking about whether or not you should use skeuomorphism.
Well, it turns out everything is skeuomorphic in this blog, but they're skeuomorphic for different reasons.
Oh, okay.
So we're actually looking at two pictures from the blog post. The one on the left has just very solid flat colors for buttons, and the one
So
on
it doesn't
the right
look like
is
buttons; they're
rounded.
just squares.
Yeah, exactly.
Whereas the other one has like a gradient and tries to look like a physical button.
Yeah, so the other one you feel like it would have a bevel if you touched it. And
Interesting.
then they're going over, which one's better.
It's somewhat of
under which
familiarity, right?
cases.
Like if I have a calculator on my iPhone, I want it to look like my calculator so I know what to do.
Yep.
So in some ways, yeah, it has to be looking like real life, but it doesn't need to have, like if it gets in the way, like I don't need it to have the segmented display, right? Like just to look, like that's silly. I don't need that.
Yeah, the other thing they talk about too is there's a trade-off. So if you might feel like I want it to look like the one in real life, but on the flip side, if it looks like the one in real life, you also expect the same limitations of a real life calculator.
Oh, interesting.
Yeah, so they actually argue both sides. So the calculator on the left, the one which just uses flat buttons, if it did some really high level math, or if it took you to Wikipedia or something, you'd be less jarred than if the one that looks like a real calculator
Makes
did
sense.
that.
Makes sense.
Yeah, so it's sort of a really interesting article, and then it goes into Apple and Google and all the big, Microsoft, all the big shots, their different UI techniques and things like that. And so thought it was a pretty good article. So
Yeah, okay. So the one I have is not like that at all. It's about a version of Minecraft that was released for the Raspberry Pi. We've talked about the Raspberry Pi before, the really cheap, small computer that runs Linux, and released a version of Minecraft for it that's for free, but it's stripped down. It doesn't do everything or in the same way. And I guess maybe I didn't. Now I'm trying to remember when I read it. I think maybe also some of the source code, or at least the ability to kind of extend it, was released so that people could kind of modify it and do other stuff as well.
yeah, there's scripting languages, it looks like.
Okay, that's what it is. Yeah, sorry.
Yeah, cool.
Yeah, so if you have a Raspberry Pi, check it out. Play some Minecraft. Minecraft's a pretty fun game. Do you play Minecraft?
I did. I played a little bit of it. I thought it was pretty cool. Actually, the coolest part for me was, did you have this thing where you could have a website constantly sitting in your server and then streaming to the web?
No.
So yeah, my friend had this setup where basically we'd have this God's eye view of our town at all times on this website. And so even
so even when you weren't playing with your friends, you could watch your friends.
Yeah, or you could have it on one screen while you're building on the other, or you could
I see.
You could see what happened while you were gone.
I think the only interesting part of that would be to like have it record over time and then be able to play it back really fast.
Oh yeah, that would be awesome. Yeah,
that would be what I would use it for.
Yeah, that's great.
Okay. Yeah, so I played it as well. I haven't played it in a long time now. I should.
Yeah, it's a shame they didn't open source it, or someone hasn't open sourced a version.
I think it's pretty lucrative to open source.
Yeah,
like it's
true.
too lucrative to them as it is.
Yeah, we read another article where they said the guy made over $100 million.
Wow.
Mojang Studios, pretty
So while we're on the topic of gaming, and maybe you could use this in Minecraft, it'd be cool. But I saw some stuff recently, and it got me thinking about virtual reality. So the Oculus Rift, which was a Kickstarter project, which is actually turning out, looks like they're going to do really well and kind of deliver on their promise. But they're trying to make a kind of affordable virtual reality headset with the accelerometer that can tell where, like when you turn your head. So when you look to the left, the view of the world pivots to the left. So it looks like you're there, right? The whole virtual reality. So I've used virtual reality goggles before, but they were really, really bulky. And at this point, I'd probably say really
outdated. Remember the Virtual Boy? That was virtual reality goggles, but you couldn't actually pivot. You had to look.
Was it the one with the red vector drawings in the inside?
Excuse me. Yeah, exactly.
Yes. Okay. Yes.
That was so bad. I mean, it gave you this massive headache.
Yeah.
So this is way better.
I guess so.
Okay. All right.
So they had like a demo where I guess they're able to integrate with a lot of the current games without much modification, which is really awesome.
Oh yeah, that's sweet.
Somebody was telling me you could have done this for a long time because basically you send the models to the graphics card, so the graphics library calls already know the distance to objects when it's doing its transformations.
Yep.
So when it does that, it can go ahead and just essentially do it twice and give you the 3D view.
Yep.
Which I did not know. It's kind of like mind blown.
Yeah, it's pretty awesome.
So this goggles are like, people are like, wow, like you see people in the video, it's like, oh, this is amazing. And it's hard to get over like the way we're used to doing input. So the way they have it now is kind of like the goggle is mapped to what would be your mouse in like a first-person shooter. So if you turn your head to the left and then you hold the W key, you start going in the direction you're looking. And so I guess people have a little bit of trouble with that, but it seems like you'd get used to it pretty fast. But I really want to try it. Like,
yeah, I totally
like watching a video is like, this is not, doesn't do anything other than makes me want to try it. I don't know that I want to buy it yet, but I definitely want to try it.
Yeah, do you know if 3D TVs have caught on? I don't think they've really taken off.
No, I don't know. I feel like the
really
coverage
like
of CES was saying like people kind of gave up on like.
Yeah.
I guess everybody has 3D TV. It's another thing. You can't not have it. Maybe is the way it's going. I don't really know. But they're going to other stuff now, like other novelties.
Cool. Gotcha.
But yeah, 3D TV doesn't strike me. Like I don't want to sit in my living room when I'm doing other stuff, wearing funny glasses and looking at the TV.
Yeah, exactly.
Like me personally, I'm not saying I don't understand it or appreciate it. I just don't want to do that. But gaming, that's different. Like
exactly. I mean, a game is made for one person per terminal. A TV is made for many people per terminal. And in this case, like just personally, like my wife and I, we almost always watch different shows, but we'll watch each other's shows to keep each other company. So for a given show, one of us will be paying half attention, right? And so to have to wear 3D goggles would just make it just a really painful experience.
Now, what if you could like? So you talk about the Ouya. What if the Ouya had virtual reality goggles?
Oh man!
And you could like both wear them.
Oh, that would be insane. We would just we'd be angry.
I feel like
birds.
you would just like run into each other a lot.
Angry Birds would have
you thought
nothing
like
on us.
the Wii people throwing the remotes through the TV.
Oh yeah, that was
just
right.
Just imagine people standing up and on the
my friend
Kinect and virtual reality goggles would not mix.
Yeah, my friend accidentally uppercut his dog like Mike Tyson's Punch-Out style, like almost jumping uppercut because he was playing Wii bowling and the dog just happened to walk in the way. And that dog flew. It was rough. I mean, we were really concerned. But the dog ended up okay.
So I mean, would you get virtual reality goggles? How much would you pay for virtual reality goggles?
I'd have to try them out. I mean, the variance is tremendous.
But like, okay, let's say they were
everything.
Not like mind blowing. Not like, oh, but like, wow, this is really enjoyable. Like I can totally wear these all the time. Like, what would you?
Well,
what would you
if
pay
you think
for
about it, so a PlayStation 3 controller costs $60, right? So you'd pay at least that for virtual reality.
Yeah, of course you'd pay $60.
Oh, I guess I'm lowballing.
Yes,
I was thinking like $100 tops.
Well, but I mean, they're essentially two TV screens in your eyes.
Oh yeah, I guess
right?
that's
like,
true.
I mean, it's at least 2 cell phones worth of technology, like
Oh man,
in
it's
your
gonna
eye,
be
almost
expensive.
maybe. So I mean, I feel like a cheap cell phone screen would be like, maybe like you'd expect like $100. I figure it'd be at least a couple $100, right?
No, I guess so. Do you know how much it is?
Yeah, no, I have to look how much the Oculus Rift was.
Actually, you can pre-order it.
Okay, how much is the pre-order?
It is $300.
$300. All right, I mean, so that's still a good price, but that's way
Yeah.
more than you were thinking.
Yeah, you're right.
So did you pay $300 for it?
Maybe. Yeah, I'm on the fence. I mean, I'd have to try because a lot of these 3D things kind of give me a headache.
Yeah.
If it didn't do that, it's a tough call even then.
See, I feel like I want it. Like I would really like it, but I don't think 300's too much.
Yeah, I'm
I
kind of
just,
in the
like,
same boat.
Maybe I'm cheap.
Yeah, I think we're both pretty cheap.
All right.
All right.
Interesting question. So the price will so it not only has to do really good, but it has to get the price down as well.
Yeah,
That's
I could
a
see
hard
them
thing.
going to 200 because the 300 also included a development kit.
Oh, ooh, interesting. So
Yeah.
maybe I don't know. All right.
Tool of the show.
Tool of the show. Okay.
My tool of the show is JS Fiddle.
Is this like where you play the fiddle in JavaScript?
That would be pretty awesome. I should look up for something like
Something
that.
that teaches you to play the fiddle
All in JavaScript.
all in JavaScript.
Using that HTML5 audio would be pretty
In
epic.
ASCII art.
Oh man, well, we'll get to that. But JS Fiddle, it's pretty cool. Basically, you can write some JavaScript, and it has a little drop down where you can choose any of a number of frameworks. So if you like jQuery, if you like AngularJS, Meteor.js, whatever you like, it's an option. So you set this option, and it gives you this 4-panel setup where one of the panels is the output. The other panel is, I think, HTML, and the other one is JavaScript, or it's, I think, CSS. And the idea is with one of these, types of files, with one HTML, one JavaScript, and one CSS, you could effectively do anything simple. And
So wait, it's an IDE?
Sort of.
Okay,
It's
I'm a
actually
little bit
meant.
lost.
It's actually meant for showing things off to other people. So you might have this cool JavaScript rollover, or you might have this interesting way of binding data, or you might have this like cool little neat thing that you want to show people. And rather than use something like Pastebin, which just pastes source code, you can actually type it in this JS Fiddle or copy paste it, and it will show you the output. So for example, I wanted to do something where when you clicked on a button, the page actually slid off the screen, and the page that was meant to replace it slid in from the left. And somebody wrote a JS Fiddle to do this. So you just give it a couple of divs in HTML, and it'll handle the sliding and all that, and it worked really well. And you could really test things quickly. You could iterate quickly. As soon as you change some of the code in one of the panels, the 4th panel refreshes. So it's kind of a neat little tool.
I think I need to do web development because I have no idea. Like I can't picture this in my head.
Oh man, well,
It's not working.
imagine a page with text
Yeah.
on it.
No.
And a little button with an arrow. When you hit the button, that page actually physically slides.
Physically.
Electrically slides off the screen.
Electric slide. Okay, sorry. I'm derailing this,
So-
but like seriously, like
No, it's pretty cool.
This sounds cool.
Yeah.
I think I need to I think visually I have to go see it. So all right, but if it's me, then it's not gonna be looking at it and telling you isn't going to be very fascinating. So we'll go to mine. So mine, I feel like I can do a good job of having you visualize this in your head. But if you go see it, it'll be so much more awesome.
Okay. I was just showing Patrick a JS Fiddle. Where, this
So
particular
it's not the
fiddle-
thing. It's not these panels that's JS Fiddle. It's this site that people can give you snippets. That's
that's it.
Oh, okay.
And so notice how when you're scrolling, you get this progress bar.
Uh-huh.
That's the thing they added.
Oh.
And so if you want that on your site, you could just leave.
Oh, so it's like a library. So you. Oh,
Yeah.
now it's okay. All right, it wasn't a web development problem. It was a Patrick's brain problem. All right. So mine is the awesome, amazing thing, and I think I've seen this years ago, but we were talking about it today because somebody had posted an IP address that if you do a trace route to it, the host names give you the introduction to Star Wars,
Nice.
which is pretty nerdy. And I guess they don't actually have that many computers with those host names. There's some trick that they do. There's a couple different ways to do it, but you do need a lot of IP addresses, I guess, to do it. I thought that was interesting and it reminded me, and I found it. There was a website you can telnet to that does an ASCII animation of the entire Star Wars Episode 4 movie. So
So like the beginning with the words. And
scrolling up and the first scene, with Princess Leia and on the ship and Darth Vader coming in. And I started to show this to Jason, and he began to say, okay, how long is this? I'm like, I think it's as long as the movie. So I think they literally, every scene, it goes by, even like the opening parts or whatever. And so it's really fun. If you've never been there, you can look on the website. It's towel.blinkenlights.nl with a K. I don't think you're going to... You can search for it, Telnet, Star Wars Episode 4. But I guess somebody had created ASCII animation for the whole movie in like a Flash thing or something.
Oh, okay.
And then somebody got all of that and set it up on a Telnet server. But I haven't watched it, so I can't verify that it's the whole movie, but I'm pretty sure it is.
Yeah, I mean, we had it up while we were preparing the show, and it was up almost the entire time, and it did not look like it was going away anytime soon. I mean, I literally think it's the entire movie at time scale. So
yeah, so check it out. It's pretty fun, funny. I don't know, interesting.
Yeah.
So you should definitely go see it. It's kind of nerdy.
Cool.
It's not exactly a tool, but
that's totally awesome. That's definitely worthy.
I feel like I need to do this kind of stuff. Like I feel like I'm such a slacker.
I was just thinking that. I mean, we should do something. I just don't know what. But yeah, that's pretty awesome. It makes you feel like you're being lazy because you didn't. This is pretty epic achievement.
Although, I mean, the guy who drew all of those ASCII frames, like, I don't know.
Yeah.
I'm not sure. That seems like I would give up after the first scene.
Yeah. I'll be like, how do you draw this bun on Princess Leia's head? And then just the sign would be staring at me.
Yeah.
I'd just give up right there. So it's pretty awesome. This guy did not give up. He made the entire movie in Telnet.
Or at least the internet says.
A lot of it. At least the beginning. The beginning half
too many
an hour.
caveats.
It's pretty epic. You guys should check it out.
Book of the show.
Book of the show.
Our newest segment. Is it our newest? I think it's our newest segment.
Oh yeah, that's right. Our still newest segment. Unless the question of the show.
But we didn't even do that. Okay, stop. All right. Book of the show.
Book of the show. So my book of the show is The Lean Startup, and it's a book that a coworker recommended.
It's about dieting.
It's about dieting your company, but I don't really know what that means.
So like working at a startup and staying lean?
Yeah, exactly. From a process standpoint. So
I'm sorry. Okay,
this is pretty cool.
I'll stop.
The Lean Startup, it's basically it's from a guy who span off a lot of startups. For people who don't know, who aren't from Silicon Valley or from a similar area like Seattle or something that has a lot of startups. A startup is effectively a group of people, they're usually called the founders, who have a new idea, something novel and interesting, and they want to take a risk on this idea that most big companies wouldn't take. So, for example, if you want to make some kind of crazy video game where it's a crossword puzzle but based on Google Maps and you play people in your city or something, right? Most new companies, they like doing things that are sort of tried and true, or they like buying startups that succeeded, right? So they'll pay the extra money to buy something that's already a good idea. If you have a brand new idea, often you have to spin off what's called a startup and try and tackle these ideas and find out what value there is there. So it turns out that going from a cool idea to something real that is sustainable and a real business is an art form. And so this guy who's done a lot of that and has a lot of experience shares that experience in the book The Lean Startup and talks about what it's like to deal with team dynamics and all about being able to capture information. So the first time you try it, you might make a crossword puzzle and the system can't handle the load and dies, and half the people who play it have this major complaint of one or another. And the whole thing might be a flop, and you might have to scrap the whole thing. But you still learned a lot from that entire experience. And being able to learn quickly so that the next thing you make can be that much better, and being able to make sure that you learned everything you could learn from each iteration of your product is what most of the book focuses on. I think it's a pretty awesome book. I'm almost done with it. I definitely would recommend it to anybody.
I feel like that minimal viable product, that's where this started, right?
Yep.
This guy's the guy who popularized that idea.
Eric Ries.
Yeah, the thing which you can build, which somebody will pay for.
Yep.
Get to that really soon.
And he used some examples. One is Zappos.com, which is now a huge site that sells tons of things. But
it's owned by Amazon now.
Oh, really?
Yeah, I believe so.
Oh, it's still pretty big, even though it's under the umbrella of an even larger company. But the idea with Zappos, it started as just a way to buy shoes online. And the way the guy actually started, he had a little bit of experience with shoes, but not much. He's mainly a software guy. he actually went to the stores. He took pictures. So he went to Macy's and even Walmart and Target. Took pictures of their shoes with his camera. Put the pictures on his computer. Made the site Zappos as if he was selling the shoes and with a little bit of a markup. And then people would buy the shoes. He would go to Walmart and buy the same shoe and then ship it to them. So he wasn't doing any of the distributing or anything. And that's actually how Zappos started. And that was the minimum viable product. Now, the reality is with Walmart or Target or wherever he was actually buying the shoes from, doing all of the distributing and warehousing, he didn't make a lot of money. In fact, he probably made no money. But he developed a huge audience of people, and he showed that this was a successful business, that people would buy shoes online, even though they're worried about sizes and things like that. So he had to deal with a lot of issues, and rather than try and get shoemakers on board and do all this craziness, he just said, forget it, I'll buy the shoes myself and ship them to them, and I'll still learn a lot about selling things online.
Because he wasn't initially interested probably in learning how to wholesale and warehouse shoes.
Right. Yeah, and so being able to do the part that's interesting and cool without the things that you might think are required is a big part of the book.
Interesting.
Yeah, it's super interesting.
Yeah, check it out.
Someone else had a sort of a Q&A site, kind of like Yahoo Answers equivalent, and he actually answered almost all the questions personally under a bunch of pseudonym accounts until it got bootstrapped. And so that's this whole thing is very fascinating, right?
Wait, did he also ask the questions?
That would be taking it a step further. Maybe he seeded it with a bunch of questions that he then answered. But yeah, just how many times have you gone to a site and it's completely empty, right? Not very often.
Like a forum and there's like 3 posts.
Oh, well, that happens a lot because it's just forum code that someone's duplicated. But I'm sure that even when the first person went to Yahoo Answers, there were probably a bunch of internal questions and answers maybe that were there. There was content. And so the whole thing is fascinating. I think it was a great book. Yeah.
All right. Well, my book, continuing my science fiction and fantasy recommendations, is Ender's Game. It's a classic. If you haven't read it yet, you should go get it now. Yeah. I believe they're now turning it into a movie, so it's almost going to be ruined and not cool anymore.
Oh, when's that?
I don't know. I think they already started filming it. So
I'll have to read it again before the movie.
Yeah, me too. I really like this book though. It's considered a young adult book, I believe. Mm-hmm. So, I think even younger kids can read it. There's nothing super violent or bad in it, but it's a really good book about kind of like a misfit boy who is like kind of the unlikely hero of a story. Kind of that is the trope it plays on or whatever. Yep. In a way, and it's interesting. I like it. It's a classic books. Probably 20 years old now, 30 years old.
Something
I don't know.
Like that, yeah.
And so it's been out. A lot of people have read it, but it's got space in it. It's got technology in the near future, not distant future, but like kind of near future. And it's got aliens. So
yeah, it's pretty epic. It has all the
Okay, this is actually pretty hard. So you can talk about the Lean Startup book and like talk about what's in the middle and the end and what it talks about. Yeah. But I feel like if I talk about that, I'm just going to ruin the book. Spoiler, so how do I feel like I need to just go on a website and like read the summary of the back of the book. Yeah. Because if I say anything more, people are gonna be mad.
It's very tough not to spoil. It's true. But you can always read the back of the book. So we should do ourselves justice by putting our own spin on it. But yeah,
okay.
I think that
all right.
I think it's a phenomenal book.
So you read it?
I've read it a long time ago.
Okay.
So my
so there's actually I guess there's many of the books in this world, I guess.
Right.
So this is the first book and it's standalone. So if you just read it and end that's fine.
Yep.
That is not a problem. But then I think it's a series of 5 books going forward. So there's 4 books that follow after this book. And I can't talk about what's in any of those books because that'll be a spoiler.
Yeah.
But then also there's other books where I don't know, these are much newer books, but they go back and revisit. They kind of start all the way over again. They reboot the series in a way. So it's the same storyline, but it follows other characters who were in that story. And it's like from their point of view. So they're the main character instead of the main character of Ender in Ender's Game. So it follows them and kind of what was happening while that storyline was going on. And so those are the shadow books. So there's like Ender's Shadow and then other people's shadow.
Nice.
And so even for people who have read that, sometimes they don't know these other books have been written and are still being written, I guess. I think he might still be working on it.
Wow.
But overall, those books are really good as well. In fact, some people say, people I know have said they enjoy those books more than the Ender's Game book.
Oh, okay. But
So,
you probably would have
so
to
check
read
it
the
out.
first one, right?
Oh yeah. I
To
think you
read
should
the
start with
Shadow.
Ender's
Yeah,
Game
okay.
and then read through it and then go back and read the Shadows. But
Yeah, but the book is awesome. I believe it's one of these things that will become a classic and become required reading and things like that. It'll be like the next Watership Down or Pride
never
and
read that book.
Prejudice or
no.
you never read. Oh, I know which one you Count of Monte Cristo. You must have really. Thought everybody in
I
Florida
mean, I know
had to
I know
read
the
that
story, but I don't.
book. It wasn't mandatory reading.
No,
Wow.
I don't think so.
Did you go to a private school or did you go?
Yeah.
Oh, that's why.
Maybe.
Okay.
Okay.
It was required in all public schools in Florida. Anyways,
Okay.
tangent. But basically, yeah, The Ender's Game is an awesome book and it's a classic, or it will be. Definitely.
Oh, here we go. Here we go. This is a good line from the Amazon review. Here we go. It says the futuristic tale involves aliens, political discourse on the internet, sophisticated computer games, and an orbiting battle station.
Awesome.
Yet the reason that it rings true for so many is it's first and foremost a tale of humanity. A tale of a boy struggling to grow up into someone he can respect while living in an environment stripped of choices.
Yeah, I feel like a lot of reviews say these kind of things where the bigger issue is insert metaphysical, revelation here. And oftentimes it's kind of lost on me because I get really into the surface of the book. So I'm really into, as we talked about this book, space battles and things like that, and the things that are happening to him very directly. And it's hard to get the bigger picture, but I think this one sort of punches you in the face with the bigger pictures.
Do you think so? Okay, so I'm of the opinion, and this is me. So do you know the story, The Emperor's New Clothes? So this is the story of the...
I think I had to read that as well, but it was a long time.
No, I think it's a story. I don't know if it's actually a book. So this is a story about I'm just going to paraphrase and skip all over the place, but to get to kind of like the point of the story is that there's an emperor who's very proud of himself, and this crook comes and basically tries to sell him clothes. But it turns out he's not actually selling him clothes. He's just pretending to make him clothes. But the emperor's really naked because the guy didn't make him any clothes.
Mm-hmm.
And so the emperor's parading down the street in his new clothes, which, if you know what's fine and you're fancy, you'll see the clothes. That's what the guy kind of tells him. So he's like, of course I see these clothes. These clothes are beautiful. He parades down the street naked. Everybody having heard that, like, if you know what you're talking about and you're able to you're of good heart, you'll be able to see the beauty of the emperor's clothes.
So
everyone
says.
kind of also says, like, oh yeah, them. And finally a little kid goes, like, wait, you're naked. Right? So this is like the story of the Emperor's New Clothes or whatever.
Yeah.
So I'm kind of like about some of that stuff that people say. I believe there are some authors who say, like, I want to tackle this issue and I'm writing this story. And I think other authors just say, like, let me write this story. Like, I want to write a good story. Yeah, and then people try to build all this stuff on top of it and like make all these assumptions.
I feel the same
like
way.
the author's trying to say this.
Yeah.
Wait, maybe the author's just saying, what's most interesting to write here?
Yeah.
Right? And then it's less of a commentary. And I've heard authors who kind of go on both sides. But, I think sometimes some of these things fall into, and this is off topic and tangent, but it's okay. Yeah. So I think sometimes I call it Emperor's New Clothes, right? Like, people get into like, the book is commenting on this and that and the other, and it's like,
you see this.
You would see this if you read it, and it's like, yeah, I see that too.
Yeah, then you feel like peer pressure, right, to agree with everyone. But yeah, I feel even more so with art. This lady will say, this red color really means that he was angry at this point. It's like, maybe he just had red. Maybe red was on clearance. Come on,
But it doesn't lessen the work, right? Like, you can still enjoy it as a piece of art or, like, as a book. It's just sometimes, I think, yeah.
Yeah, I think people try and take it too far so that they can iconize that particular work. And so they want it to be unique. They don't want someone else to basically copy that style. So they attach all this feeling and sentiment, and then you assume, only one person this other person can't have the same feeling as this guy.
Yeah, I think sometimes like reviewers, like that Amazon review saying that, like, the first part was cool, but then the second part, it's kind of like we're being extra insightful.
Yeah.
Read this book; it'll change your life forever. Like, okay.
Yeah, exactly. All right, so this show is on unit tests.
So to understand unit tests, maybe we have to step back into our time machine in our futuristic traveling science fiction episode.
That's right.
And look at the history of testing.
The history of testing. Yeah. So
first there was a guy sitting under a tree, and then an apple fell.
And you learn next time to build a umbrella. I don't know. But the idea is, Patrick and I are big fans of unit testing, myself especially, and this is one of these things that even when I was in college, I don't know about you, but I always thought testing was kind of for suckers, and it's one of these things that sounds cool, kind of like proofs.
My code always works the first time.
Exactly. Yeah. I mean, it's why
when I write it in assembly.
Yeah.
I always knew that. You knew that kid in college? Was always that kid in college.
Yeah.
I don't do Java. This is stupid. I write all my code in assembly. And it always works the first time.
Oh, no. So, yeah, I mean, that's the thing. You feel like, doing tests is like doing proofs. The reality is, at least in machine learning, I can say with authority that almost all proofs are BS, right? The reality is most algorithms require some kind of fudge factor or a bunch of knobs to turn, and you have to kind of get that right. And there's all sorts of corner cases where the algorithm fails, right? The algorithms that provably converge are useless and things like that. And so I kind of took this sentiment over to unit tests and said, it's one of these things that's cool to talk about in class, but we'd never use it, right? Turns out that unit tests, as we'll see from their history, have evolved to the point where they're now extremely useful. So the very first unit tests, they call this the era before 1956, the debugging period. And the idea here is, if you said I was writing a test, what it really meant is you're running your program and trying to see
seeing
if it
what
dies.
happens. Okay, yeah. Looking for the failures, the bugs.
Yep.
All right.
So what was the next period?
The demonstration period. So this was, and testing was, I run my code and did it do everything it was supposed to.
Yep. Yeah, exactly. So you have a list of, you maybe have some golden file. Like the code should output, 1, 2, 3, 4, 5. And you just check the output of the file.
I run my GUI. Wait, do we have GUIs? This was 1978. So
yeah, I think they had GUIs. Maybe. Yeah.
Okay.
They definitely
you
had
run
GUIs.
your program. Yeah. Make sure it does what it's supposed to. And then that was followed by
the destruction-oriented period. And this is where people kind of felt like testing should find errors. So the idea is, in this phase, you'd compile, your code would compile, and then your code would test, and then your code would run. So you would write tests that would do things like run a function and give you an expected result. The very sort of what we consider now is the simplest possible unit testing was started around the
because you
late
try
70s.
to break your code. You try to give it stuff that'll make it fail.
Yeah, exactly. So then there's the evaluation period, and this sort of takes it to a higher level. This says that testing should actually measure the quality of your application, and this went on from around 83 to 87. And so the idea here is, maybe you're writing a bigger app or a distributed app, or you have many users, things like that. So you want your testing system to sort of be more reportive. You want it, maybe you every now and then are in a situation where something fails. You're writing big apps, which parts of that fail constantly, let's say. You want to just get an overall feel for the quality of the app. So is it performing is it doing 90% of what I want it to do? Maybe you have these 2 or 3 features which are either completely broken or semi-broken, but most of the app's operating the way you'd expect. And then now we have the prevention-oriented phase. And so the idea now, the sort of mindset for people writing tests now, is that the point of testing is to sort of detect and prevent faults from occurring in the system. So this involves sort of an amalgamation of everything, all of the other periods combined. So testing should be part of your runtime framework. It should be something that you do almost as an extra compilation step and everywhere in between.
So a unit test, I mean, we say it, a unit, but what's a unit? I guess that's subject to definition, to differences of opinion of what a unit is. So I worked a job once where unit testing was like kind of what we talked about in the history here, that you run your program and it runs on a set of input and produces a set of output, and that you're unit testing your thing,
right.
your program, right? Your whole program. It's some or you're at least you're testing like a whole set of classes and stuff all together at once. Right. And you're testing that they do exactly what you define, and that was a unit test. But I don't think that's what unit test is really supposed to be.
No, that's a good point. So we're covering unit tests because testing itself is as big as programming, but there's also other types of tests. So there's regression tests. So let's kind of break them down. So
are we going to try to do all of them?
No. We won't cover all of them because that'll take forever. But we'll give one sentence of each of them. Unit tests are, at least is my opinion, and you could feel free to correct me
You're
or
wrong.
bounce ideas off.
Not yet.
Dang it. Unit tests are testing, for example, one function. You have some function foo, and it's supposed to take A and transform it to B. And you call foo a bunch of times with expected B's, and you give it some A's and expect B's, right, for foo.
I would diverge slightly because I think sometimes like that can be an overuse of unit testing to say every function needs a test, and I've certainly had code that does
that's
that.
true.
But it's like
That's
the smallest something of which has meaningful test results.
Yeah.
Like you're doing, so in other words, if you have something which isn't doing any decisions, it's not doing any kind of math, it's just like very, very basic function, like a get method.
Right.
Some people are like, oh, you need a unit test to get method. Well, I mean, if there's a problem there, you've got worse problems. Now, a set method, if it's doing some sort of checking, that might need unit tests.
Mm-hmm.
But in general, like, writing a unit test for just a simple set and get method that doesn't have any sort of balance checking or any of that, it's probably overused. So saying function, maybe not. Maybe you're calling another function which calls that function.
Yep. Yeah, so there's it gets to another point about coverage, which we'll cover later. But yeah, that's totally true. Another thing is, other than unit tests, are regression tests, and these are a little bit larger. So this gets to what Patrick was saying.
So that's not a size change though. Like a next thing would be like go like to maybe like a system test or an integration test. Like going up the scale. This is interesting. So you can kind of like go up different dimensions, right?
Mm-hmm.
So like you can go from like a unit test to like testing multiple units together.
That's
right?
regression.
An integration test.
Oh, it's integration.
So you're integrating
right.
multiple things together and then you get to like your whole system, which is composed of subsystems and parts. And depending on the size of your project or the scale, you may have many levels in between. You may define them differently. But then a system test is like kind of testing the whole, everything all up together that it runs. Given an input, there may be many calls down and back up and decisions, and then it returns something. And you're testing the whole system at once.
Mm-hmm.
And that's kind of where you typically requirements are written against the system. And so you're testing that you meet all the requirements.
So what's a regression test?
So regression test is you have the system test, and now you change something in the system. And your regression test is you test that nothing changed between the two if it wasn't supposed to.
Oh,
So I run the system test again, and then I check that nothing changed, or it changed in the way I would expect it to.
Gotcha.
So like I worked once doing some banking software. And when you do banking software, they really want to make sure that you have a whole suite of regression tests. But what that means is you run the suite of tests.
So pro tip, people, banks don't use floating point.
That's true. So it is all fixed point math.
Yeah.
And so you take the numbers and you run them once, right? And like with your current system, then you want to apply this change. But you need to prove that the change doesn't break some of these core tests. So it's not so much, that's why I'm saying it's a different dimension, because you're not testing more or less, you're testing it from point A, like time interval 0, now at time interval 1, do my results match? Or can I explain why they don't?
Oh, okay.
And that's what a regression test is.
I always thought a regression test was an integration test. I don't know why, I just never really thought.
I might be wrong, but that's how I've always.
No, what you're saying makes a lot more sense. I mean, I know it makes more sense given the word regression.
Regression, like have you regressed? You want to prove that you haven't made something worse.
Yeah, exactly.
Right. So
so there's integration tests where that's more for where you have, say, a set of functions and you have expected output for that functions. Maybe that output is in a file or something like that. But it's not the typical output. Your system might not deal with files. It might be some web service. But you have an input file and an output file just to test this core piece. And so that would be an integration test. Then, as Patrick said, the highest level is a system test, where if you're making a website, you would actually have, so there's something called WebDriver, where it can actually start up Firefox and click buttons and tab and type things in input boxes as if a real human was doing it. And so that's the highest level in the pyramid, right? So system test is where someone's literally, you bring up a test server with your website on it, and then this computerized agent goes on and types some fields in and registers an account or something like that. And that whole process should succeed.
So then you can get into even another dimension. You get black box, white box testing. So black box testing may be like, you bring up the fake version of Firefox, you type this stuff in, then you try to log in once you've created an account, and you make sure that works, because a black box treats the whole system as a black box, so I don't know anything about it. So this could be done by an outside person, a contractor who's not working on developing the source code could be done, pretty much should be by anybody, right, who just understands how the system's supposed to work.
Mm-hmm.
But then other tests like unit tests can only be white box tests.
Oh, I see.
Which means you have to know, you're testing something specific on the internal. So like a white box system level test may be like, I create an account at the form, and then I go and check that it's in the database.
Oh, I see.
Right? So like now I'm doing white box. And then there's gray box, which is like in between, and like this is kind of trying to treat from a different look at the system.
Oh,
right, in a
that's
different way.
I'd never heard that either. So for people who have, if it isn't completely opaque, Patrick is way better at testing.
Whoa. I don't know. That's hang on. But so I think one of the kind of ideas, there's many ideas in many different spectrums, but one of the things about unit testing is if you kind of go down and you say, I'm testing the lowest level and I'm making sure that that's correct, then you can build up. Because then when you do an integration test, you're not trying to retest what you tested in the unit test,
right?
Which is a common mistake. I think when I was starting out, that's what I did a lot. Like, I need to retest at the same thing, like run the same test. But you don't really. What you're testing is interfaces. So I assume people have unit tested each of their individual parts, and now I need to test how they interact together.
Right. I mean, if you think about it, the entire test suite is meant to be run, as one unit, right? So if your unit test tests this function and then your regression test tests the same function, then you're just kind of wasting your time.
So yeah, you don't want to write an integration test which is
integration test. Yeah, I said regression test.
Oh, sorry. You don't want to write an integrate. For instance, like you had an RPC, a remote procedure call, and has a client and a server, and then it executes sum these two numbers together. You don't want your integration test to have the purpose of, I'm writing an integration test which has the client call the server with the numbers 1 and 1, and then I get back 2.
Right.
For the purpose of testing that bottom function is doing 1 + 1 = 2. I mean, you do need to write probably a test that, make sure that you get back the right answer, but you don't need to go through all the corner cases of the bottom most unit there.
Yeah,
you need to test all the different ways of calling. That's what you need to be focused on.
Yeah, so a better way to do that, just to finish Patrick's point, is you could make the RPC with 1 and 1, and you could call the function directly with 1 and 1. And in both cases, you should get the same answer. And the nice thing about that is, in the case of adding, it's obvious, but let's say you change that function. Like, let's say 1 and 1 really is now equal to 3. For whatever reason, that logic has changed. You don't want to have to go back and change your integration test to change a 2 to a 3. You want to change your unit test of that function, and then the integration test should still work fine.
So that's how you kind of you build up. But unit tests themselves, let's isolate down to this, or else we're going to spin for a long time.
Yeah.
So we kind of talk about one of the things that there's this very beautiful notion in computer science of getting to provability. Mm-hmm. Like I want to treat my algorithms like math, and I want to be able to generate proofs and have provably correct statements. And to some extent we get there, we don't get there. But the harsh reality is most of us don't have the time or freedom from our management to get to the point where we can do provable correctness for our code. Mm-hmm. And also the systems we run on and the environment we run on don't even allow for that, even if you wanted to.
Right.
But unit tests try to help us get there. They say, what are all the possible ways to kind of use this unit, this base of function, this minimally viable piece of code, and what are all the different ways to test it? And if I test all of those, then I should have provable, at least to some level, I should be able to prove that it's correct. That people can call it and assume it's going to work.
Right. Yep.
And that gets to an interesting point about, and we'll just gloss over this, about whether you should write the unit test before or after you write the code.
Yeah, I've heard both ways. And I actually started writing the tests after because that's sort of the more intuitive thing. And plus, you want to get the cool thing done. Right? But I've found lately I've been writing the tests before. And this gets to something else that I think is really interesting is just to finish the story, when I started, I thought tests were boring and kind of lame and no one really used them. But now I realize the cool thing about the test is that you could put your functions or your system under a state of distress that it will never see in the real world.
And that it would be very difficult to replicate at a system test or an integration test.
Yeah, and to be able to see that is really cool. So for example, you might write something that reads and writes records, like the zombie DB, for example. I wrote that zombie database, right? And the cool part really was writing the tests where I had 128 threads concurrently trying to read and write elements, and then checks to make sure that the database wasn't corrupted, right? that was really cool. And the first time I wrote it, it completely failed the test. I mean, it completely, like the first record crashed the system, right? And then slowly I got it to the point where it was more and more robust. And it reached a level of robustness that in my entire web app, in that Trivipedia, nobody would have ever, like I would never have the type of bandwidth that would have caused these issues to come up. But making something that was robust enough to handle these scenarios was actually really interesting and fun. And so the writing test part was actually one of the funnest parts, even though it seems one of the I need tests for my grammar.
I'm sorry.
It's one of the most fun parts, even though it's, canonically it's stereotyped as really boring and mundane. So
we alluded to it before, but code coverage. So this is one of the things that, how many unit tests did you write? So one might, early in their career, and I think everybody did this, but I know I did, you kind of write a test to make sure that the plus sign is plussing things, or you check that something is null, but then later you also check that it's null, like that it hasn't somehow not been null again, because you feel like for sure that's happened to you once.
Yep.
And in reality it was something else you had messed up. But you really you keep checking and checking. So you can write, like an insane amount of, lines of code trying to test the same thing. And so we talked a little bit about corner cases. So, kind of the method is you're supposed to test the different kinds of tests that are the corner cases of what you do. And if you test those, that should be sufficient. And that kind of interplays with another thing, which is code coverage, which is saying you should be able to execute every line of your unit when you write your unit tests. Because if you don't, you could be a sign of problems. Mm-hmm. One is, how do you know that code that isn't tested is going to work? You don't have a test for it.
Yep.
And the second thing is, if there's no way to reach it, then it shouldn't be there.
Yeah, exactly. Yeah.
And I've had this before, through one way or another, it turns out there's an if statement that because of previous if statements and exception checking and handling and throwing, you can never reach that set of code.
Yep.
But you put it there because you weren't sure. But now, going through the unit test makes you realize you can't construct a test case that ever exercises that. Then it should just be removed.
Yep. Yeah, definitely. Another cool thing about unit tests is one of the strengths of unit tests is that they actually force you to write better code. So, for example, when I very first started really getting into writing unit tests, I kind of sort of decided to just jump into the frying pan and unit test this code that I had just written. I was like, I'm going to do this and find out how this works. And I realized that my function didn't have any inputs or output. It had one input, which was just a file that it read data from. And it had one output, which was the name of the file that it output to. And I realized that it was impossible, and it was one function. And I realized it was impossible to test this function. I mean, it didn't even make sense because it was such a black box and it had been designed so poorly. So the first thing I did was I took the function and broke it into pieces. And I said, okay, this piece, inverts a matrix. And so I can invert, I don't have to invert a matrix from a file. I could just give it a list of numbers and tell it to invert that matrix. And this other piece does something different, etc. And it got better. But in the beginning, my very first unit test took 10, 20 minutes, and it actually wasn't even a unit test. It ended up being a system test, right? So
take that example a little further, I think, because it gets into the other point. So writing testable code, that's very important. It makes you write your code differently. But then to go a step further, and we're going to talk about where kind of mocking comes in. Mm-hmm. So Jason's saying he has a function which reads a file that the path is given to him, mm-hmm. reads a matrix out of there, inverses the matrix, and writes it back out. We'll just say that's the code he wrote. So he wrote all of that in one function to start. Testing that is near impossible.
Yeah, exactly.
So what he can do instead, he's talking about inverting the matrix function out, but now he has code which takes in a file path, reads the matrix, reads the matrix. That sounds awesome. Reads the matrix.
Dials the operator.
calls the inverse operation, gets the results, and then writes it out to a file. So that parent function there, the one that's still doing too much, but also that's also really difficult to test. And you don't want the whole kind of one of the goals of unit testing is you don't want that test that tests that function to also be dependent on the test for the matrix inversion.
Right.
So instead of calling the matrix function by name, Jason could create a class which encapsulates the matrix inversion, because then maybe he has different kinds of matrix inversions depending on whether it's a very, very big matrix or a very small matrix or a certainly shaped matrix or a sparse matrix.
Yep.
So all those could be different matrices. So now he has a class which represents that, and instead of having to go create a test instance of that which doesn't do anything meaningful, you can use a mocking library. What a mocking library is a way you can create mock objects on your own, which just say test matrix inversion class, which doesn't do anything other than just return the matrix you got.
Right.
And you can write that on your own. That's perfectly fine. But you may end up having to do that a lot.
Yeah, you don't want to have to do this. For every class, you have some dummy class that does like nothing meaningful. I mean,
Right.
that could be such a waste of code.
So what a mocking library does, and they have these for many different languages, but the root thing is always the same, is allows you to tell it like, I want this object, but I want it to be fake.
Right.
And then when it's called, just return this.
Yep.
And then once you run your test code, you check and say, was it called in this way? And how many times was it called? And what was it called? You can kind of do all those checks. And then you check that it was called appropriately, that it was called correctly, and you're not dependent on that. You're not dependent on the implementation of that class, just on the definition of the class, the interface of the class, which is all
Right.
you want to be dependent on.
Yeah, so getting to Patrick's point, let's say you just had a file let's say each line was supposed to have a matrix on it. So you gave it an input file with 3 lines. The matrix inversion function should be called 3 times. And the mock, what it will do under the hood, it'll actually have a counter for how many times the function was called. And it'll tell you, hey, you actually, the very last line of your file was just an empty line, but you tried to process it as a matrix. So your matrix inversion got called 4 times instead of 3 or something like that. It'll actually, the test will fail for that reason.
But then the function still is not, to go this example a little farther, lest people think we're not doing justice, you still have this call down to the OS there, which says, open the file.
Mm-hmm.
And that's still problematic, because you don't want to do that during a unit test.
Yeah, right.
Right? And also, in general, like as a engineer, you shouldn't be doing that, because what happens if somebody wants to port that from one operating system to another?
Yep.
So then, now, you see where this is going. Now, instead of passing in a file string, you need an object which represents how to open the file so that you can abstract that away. Mm-hmm. So you can kind of begin to see how you have object-oriented programming, unit testing, mocking. They kind of like are swirling together here.
Yep.
And you can be poor at some of those, but if you really get involved in starting doing the whole process, it's going to make you better at all of them.
Yeah, definitely. That's definitely true.
So I didn't think so. I thought unit testing was a ways, and then I started doing it, and I was bad at it in the beginning, and then I got better at it, and then I learned I really, you have these things you hear like separation of concerns and testable code and, all these things. And it really it became like, this is just people just wasting time and fussing. But in reality, once you learn to implement all those things, you learn why there are those design patterns and why things are important to be written in a certain way, and you build better code.
Yeah, and historically, I look at the projects that I've worked on, side projects that have succeeded and failed, and real work projects too. And I've noticed a trend that, especially with my side projects, they get to the point where they're not easily testable. Like whether I'm writing unit tests or even before when I just tested it by running it and seeing what happened, the point where they stopped becoming easily testable is right the point where I gave up. So for example, I made this hockey game, and the hockey game came out pretty cool, but I had bugs such as, at the end of the intermission in between quarters, it would sometimes crash. Or the statistics for many games, after you play 20 or 30 games, the statistics were not being calculated right. Bugs that required you to play 20 games because I had no tests. Those things, when I started encountering those bugs, I kind of was paralyzed. I mean, there was a bug where after 20 minutes it crashed, and I would literally play for 20 minutes, wait for it to crash, and then see if I could catch this bug. I did that a few times and then gave up, right? So a lot of these projects, the testing is sort of what can keep you sane when you're going through it and kind of keep you motivated. And plus, it's pretty cool to write a test and to actually see some bit of code do something meaningful, even
far
when you're
before
not done.
you might, but far before you might be done otherwise.
Yeah, definitely. So it's a way to sort of give you motivation.
Yeah, and that is a problem with a system test, right? So if you only do system testing and you wait to the end, there's so many potential problems. Like you spend tons of time debugging. Versus if you have unit tests, it kind of tells you where the likely culprit is. If all your unit tests are still passing, And then that goes to another thing is like when you do find where the problem is, because you might still have to kind of go through all your code looking for the problem, but you finally find your problem, you should figure out why a unit test didn't fail.
Yeah.
And write a new unit test to make it fail.
Yep.
So we have this procedure where I work now where if somebody has an issue and it caused a problem, you can't say you're done until you wrote a unit test that makes that problem appear and show that it's like as part of the fix, you have to make a unit test that failed before the fix, you implement the fix, and then now the unit test passes.
Right.
So to prevent somebody from getting into that in the future. And also for another good use of unit testing is it's kind of like documentation. So we all hate writing documentation and comments in our code.
Terrible.
No matter what we say, we never write as many comments as we should. And the nice thing about unit tests is it is a concrete example of how the function should work.
Yep.
So if somebody doesn't understand how something's supposed to work, and you wrote good unit tests, they should be able to look at your unit test and say, oh, he's testing it in this way. Well, why is it? Oh, because it does this. Oh, I see now. And there's many times I worked on legacy code where it had, thankfully, reasonable unit tests, and I could go look at it and actually figure out what it was supposed to be doing because the comments were terrible.
Yeah, I saw one place where the code was, the comment said, we want like tangent y over x, and the function returned y divided by x. And I couldn't get it. I went over to the person. He said, "Oh, yeah, because y and x are very small, and when they're small, the tangent function's equal to the line y equals x for small values." And it's like, at least provide a unit test or some comments or something. If you provide a unit test and your tangent function returns y divided by x, and you have unit tests, you'll be more inclined to think, oh, I should probably write a comment here, because even to me, calling the tangent function and getting the divisor, the ratio, doesn't make sense. And so it's sort of, as Patrick said, it encourages you to feel like the person on the outside calling the function. And if you think about this, for people who work on open source or people who are in a job environment, so you're writing your code. Then later on, you're going to read it. Maybe later on is an hour later, a day later, a year later,
10 years later,
decade later. You're going to read that's one person. If you have anybody on your team or anybody on the internet is looking at your project, that's two people. So at minimum, twice as many people are going to read your code than write it. So it took you to write it, but 2 times you are going to read it, minimum. Probably more, like 50 times or 100 times that code's going to be read for each time it was written. And so just testing is sort of a way for you to just keep thinking about that and putting yourselves in the shoes of the person using the code.
So there are some weaknesses, and I mean we can continue to talk about all this awesome, but some of the weaknesses is that it can get to management, it can seem time consuming, and even it can get, even if you're doing a really good job, you're not overdoing the testing, it still can take a lot of time to write unit tests. And especially if you're not writing them as you go, which is really bad, you shouldn't do that. And then you kind of get to the end, oh, I'm almost done, I just have to write unit tests. Yeah. Not good.
I have to admit, I've done a couple of things at my current job where somebody said unit tests question mark as a reply. So I'd send all this code out. I'd say, hey, take a look at this cool thing I made. And let me add it to the system. And someone would just reply, unit tests? Turns out there's none. So, yeah, all of us can be guilty of it, and it can feel like a big problem. But yeah, it's just something that you start to live with. Another weakness is you can establish some constraints that might not be valid. So as Patrick was suggesting too with his addition example, right? You might have some function that does X. Let's say you have a function that, let's say you have some machine learning algorithm, right? And you run your machine learning algorithm and you give it a bunch of data and it spits out 4.3 for a prediction. So you write a unit test where you have this as an input and you expect 4.3. That's a very specific number. I mean, if you make any change to your implementation, it'll probably change. It might become 4.2999, or it might become 5, and maybe that's okay because the algorithm has changed in some way that's meaningful. So one thing that you have to be really careful about is writing the unit tests in such a way where they test the idea, but in such a way where they aren't just very fragile and break because of things that don't really matter. And so this could be really difficult, and sometimes it's impossible.
Hard coding numbers leads to this a lot.
Yeah, definitely.
So you have, like, you're using an enumeration provided by somebody else, and instead of going and trying to reference that enumeration, you put the number in.
Yeah, you put 2.
And then they change it and it all breaks.
Yep.
The other thing is, related to kind of like establishing false constraints, is just in general, you can get a false sense of what the code is supposed to do or how safe it is or how reliable it is because, it's got unit tests. It's like, yeah, but even if the unit tests cover all the lines of code, even if they cover all the branches of the code, even if there's a lot of them, doesn't mean they're testing the right thing or the meaningful thing or the crazy cases that could cause your system to fail. And then when it fails, like, I don't understand what happened. It's unit tested. It's like, well, so you got to be careful about those things because one bad thing about in the way, there's different ways of doing it. So many people have where unit tests are supposed to be written by somebody different than the programmer. And the reason for that is that if you as a programmer write the unit test, you have the same assumptions in your code and the unit test. So for instance, like this tangent function, this guy says, it's fine to take the divide the two numbers because for small numbers that's okay, right? Well, what if it turns so he writes the unit test to reflect that. But then what if he doesn't have any test that the numbers are sufficiently small? And then somebody comes along and uses big numbers or reuses his function, right? So because not just anybody wrote the unit test, he wrote it with the same assumptions. He only tested small numbers. Then that's a false sense of, that's a bad thing. Like he wrote it with this. Versus if somebody else just said, hey, we have this tangent function, and that's it. Write a test for it, right? He's going to write tests for all sorts of numbers, and then that's going to force the programmer to, have check to say that this isn't too big of a number, and that makes everybody's life better.
Yeah, definitely. That makes sense. Yeah.
So you can write unit tests all on your own, just like you can write mocks all on your own. You can do all of this stuff without any outside tools or help. But
that would be painful.
Yeah, things are made better when you have tools to help you. And so we have a couple here. We're not going to talk about them all. Many programming languages have choices for what unit tests you want to do, for choices for mocking. But
there's a bunch of them, so feel free to explore. Wikipedia has literally a gigantic table for each language.
So Java, JUnit is the most common?
Yeah, JUnit, that's the one I've used as well, and I think it's great. I think it's pretty cool. It has a lot of cool settings. If you use Maven, it works well with Maven. It'll let you run tests in parallel, which is pretty fun if you have a lot of multi-core machine and things like that. So
then you can mock with EasyMock. Yep. Makito.
Yep.
I'm sure there's more. And those can have different strengths and weaknesses, and there's different whole different ways of mocking where some you tell it like it's going to call this, then this, then this, and then you call it like a replay, and it's going to replay all the calls you gave it. And other ones you just say, here's what to do, and then you check in the end and say, did this happen, did this happen, did this happen. So there's kind of different ways of even doing the mocking. C++?
Yeah, C++ has CPP test, which is pretty cool. And on the mocking side, it has gmock, which is a pretty fun library. And C++, because of, it's kind of such a hacky language anyways, the mocks are really hacky, and they use all these crazy compiler definitions, things like that. But there's plenty of great tutorials.
Well, mocking in general is kind of like one of those funny things where you use a lot of programming things you wouldn't normally.
Yeah, I mean,
people in the mocking library.
You're trying to inject. You want to keep the class so that the person using the class doesn't know the difference. So you want to keep the signature of the class the same, but at the same time, you want to inject all this custom logic.
That's right.
And so, that causes craziness to happen. But the good thing is these libraries do the craziness for you, and they provide an API that's pretty simple.
So if you do all the unit tests, one thing is you can do code coverage. That's a good thing. You can.
So what is code coverage? A lot of people don't know.
We mentioned it briefly, but code coverage is saying how many, there's different forms of it, but the simplest is statement coverage. So how many of the lines of your code, think about it that way, are executed when you run the unit tests or whatever test. Yep. So line 5, 6, 7, 8, and 9 were all run. You got 100%, 100% because the lines before that and after that are comments and curly braces. Great. But then if you have like if statements, you'll have only 100% code coverage if the if statement is evaluated and if the inside is evaluated. The problem is there's this other thing called branch coverage, which says like, what happens if different branches are executed? So you could get, like, for instance, a null pointer exception if you have a badly stated branching, but you only have 100% statement coverage. You wouldn't ever necessarily detect that has a null pointer exception.
Right.
Versus if you have branch coverage, you could potentially catch that, because branch coverage says every part of the branch has to be evaluated.
Yeah, right.
So that's kind of code coverage, and you need tools for that. Like, I mean, you could write your own, but it typically has to do some sort of instrumentation so that when the code is run, it is able to have things that run before and after the code to know which lines are running.
Yeah, exactly. Yeah, and so, don't do that yourself.
Yeah, bad idea.
Yeah, but if you go to Java has a bunch. I actually I haven't used any of the open source ones, so I can't really comment, but I'm sure they're great because most of the stuff, I mean, you think about it, if you write a testing framework, you're already a pretty good programmer. I mean, if you got the moxie to say, hey, world, here's a testing framework, everyone should use it, then you probably know what you're doing. So there's definitely good code coverage tools for all the modern languages.
And then another thing it enables is, and this is a concept I think we've talked about before, but continuous integration. So continuous integration is that every time somebody submits a change into the repository, to whatever your source control is, the system, there's something that runs which rebuilds everything and runs all the tests.
Right.
So every time there's a change. So in many places, people just make changes all the time, willy-nilly, and then occasionally somebody kind of checks out a version of all the code, runs the test against it, and see what has happened. And continuous integration says, no, that's a terrible idea.
Yeah.
Let's have what's called like a build status, like, oh, currently tests are broken or the code won't compile. And then when somebody does something wrong, you can email them, you can notify them, you know when something's bad.
Yep.
And you're just doing this all the time. And when you have unit tests, it helps with that. So if somebody makes a change to your code without updating the unit test or testing it, you know immediately if something's wrong or broken.
Yeah, and again, don't write this yourself. I think there's Jenkins in Java, and there's a bunch of other ones. But they'll do all sorts of clever things. Like they'll run all your tests daily, and then if a test is broken, they'll do a binary search between today and yesterday to quickly find out exactly what change broke it. So they're pretty awesome, and take advantage.
And that's
of it.
obviously more important for a much larger team. I think unit testing can even be important if it's just you.
Yeah, definitely.
But continuous integration is something probably more suited to a more distributed and larger team.
Yeah, it's probably overkill for a pet project, but yeah, it's definitely good.
So unit testing, we got a lot of other kind of testing stuff. We'll probably have to do more testing episodes in the future.
Yeah, we'll have to do a part 2.
I think programmers think we all assume it's dry and boring, but it can be very interesting and it's very important.
Yeah, and I think, as I was saying before, some of the stress tests that you write when you're unit testing cause you to do things in a different way or learn things about the system that you wouldn't have otherwise known. So, for example, a really simple example was I had a system that basically did a bunch of math, and it sort of tried to hone in on a certain number. And when I wrote unit tests, I found out that if I gave it a certain set of input, the very first unit test just picked a bunch of random numbers and then tried to train it, and then saw that the number it converged to, that it actually converged. So in other words, given a bunch of inputs, the output should start off crazy. It should be, negative 100, then 4,000, then negative 10,000, but it should eventually settle down. So it might settle on 3 million. I don't know what the final answer is, but it will get to a point where every time you run that function, it would give you some number in really close to 3 million, or really close to some x. And I found out that for certain inputs, it would just oscillate wildly, and it would just give you crazy numbers, and it never settled. And it turns out that algorithm, the fundamental math behind it, was broken. And so I wouldn't have found that out without unit testing. And so for that reason, it can actually, it could give you insight into something that you just wouldn't have had otherwise if you had just, ran it out on your input. Yeah.
All right. Well,
cool. Till
next time.
Yeah, have fun writing unit tests.
Woohoo!
Let us know if you write unit tests first, and if you do, how that affects your. If that was a cool experience.
Tell us how we're terrible testers and we got it all wrong.
Yeah, we have the discussion section people have been posting. So if you have any cool discussions,
so we have Google Plus community.
That's right. The discussions in the G Plus community.
Or you can comment on our Plus page.
We have the Plus page as well. I'm still
So
not
there's
sure.
there's many ways to contact us.
Yeah,
No
there's-
excuse.
There's the blog, the Plus page, there's the community.
Yes.
and-
Oh, also, and you can email us.
That's right. You can email programmingthrowdown@gmail.com. And those are all great ways to reach us and let us know how these things turned out.
All right. Thanks for listening.
See you later.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.